I'm Amber.
Hi, I'm Nate.
I'm Robbie.
I'm Biagio.
And our project is HomeworkHub, a social media platform for students to upload and view homework assignments.
In the architectural spike, we defined a clear set of requirements for a minimally viable product for our project. We oriented ourselves with technologies we feel that best provide the functionality required to meet our project's needs. We collected a set of resources to reference when we run into roadblocks in the future. We created simple demos that meet the goals we defined.
Our primary short-term goals were to establish a working site where images may be uploaded and viewed, register users, and store user information in a database.
Our secondary goals for upcoming cycles are to sort pages by some subject, university, course, or professor, adding a search implementation, allow users to vote on content for relevance and accuracy, giving users the ability to post anonymously from their registered account, and additionally using cookies to log session information.
We defined two flows for our architecture on the website. We defined a read flow, which the client makes an initial request to the web server, and the web server will then query the database for post information. The database responds with post data, and then the web server will generate an HTML file and respond to the client with a list of posts. The client can also choose to post an image to the web server. The web server will then store metadata about the post, such as the date created and course information, and will also associate it with some path to the file on the file system.
Our ultimate goal during the architectural spike was to create the minimally viable product for purposes of demonstration. We broke down the vision of social homework into what we believed was at the core of the working product.
To work more effectively, we took our larger, more vague goals and divided them into smaller sub-goals as part of the MVPP. For us, this meant creating a web server to serve a static site, making a simple and clean way to view content, and implementing some upload functionality, allowing users to add their own content to our site.
Our plan for the next cycle is to define a single repository that encapsulates all that is required to run the project on a local machine, includes bash scripts to create a database, and defines a valid execution context for the web server, securely stores user information, and includes a session handler.
We would now like to show you some demos that demonstrate the accomplishments we have achieved so far. The first demo is a simple static site where the user content can be displayed. On the right-hand side over here, you can see we defined an HTTP server in Go that will just simply serve up content from the current directory. I can run this project by just typing go run server.go, and if I connect to this page, localhost 3000, we can see the interface that we created to search and browse through posts on the social homework site. You can also see on the right hand side over here we have simple navigation functions for filtering through courses and subjects. You can also see we have a login page that allows users to create accounts and log into the site. Currently this isn't functional as it's just a static site. And that's it for the first demo.
The next demo would be to show how we can, or in this case cannot, upload an image file to the site. And so here we're going to be demonstrating the file upload script that was also written in Go. I'm not going to spend too much time talking about the actual code here, but we will demonstrate what it does so far. And so by simply typing go run file upload.go, we will start the connection with our static site, and then by going to localhost 8080, we get to where the static site is hosted and go to the simple HTML form here. We can browse files from the computer. And choose any type of image file, PNG, JPEG, or it may be. Use that file and go to upload, and this is the error that I've encountered at this moment.
Next, we will show the hashing and salting of a password. In this demo, we will show how we hashed and salted a password. When you type in a password, it will return a string that has been hashed and salted. And if you type in the same password, it'll give you a whole different string. Also, we will show our script that creates a database in a table. In our final demo, we will show how we are able to run a script in Go that is able to create a database and put a table in there that has columns ready to be filled. Now when we get onto MySQL, we can run show tables, and the table that we just created should be in our list of tables.
A large part of our MVPP was spent planning on how to implement the goals that we had set forth. We decided on using Twitter Bootstrap to set up a simple front end, choosing Go as opposed to some other back-end language, and using GitHub to manage functionality created by individual group members in a collective where we could all easily contribute and keep track of each other's work.
We also used curl to test server endpoints, MySQL for storing user information and post data, and we used various other internet resources to help orient ourselves with the project.